Alright, so we're going to begin with section R-4, polynomials and multiplication of radicals. And let me zoom in a little bit just so we can get a little bigger print there. Okay, so first the definition of what a polynomial is. So a polynomial of degree n and the variable x can be represented in this form. I'm not going to read through all of it, but what you want to notice is that your n, well, let's read through it. So it's in that form where each coefficient a sub I is a real number, a sub n is not 0, and then is a non-negative integer. The leading coefficient is a sub n, and the degree is n. Okay, so n is some non-negative integer. And so you'll notice that you start with the exponent n, and then the next term has the exponent n minus 1, which means it's dropping, yeah, n minus 2. It drops all the way to 2 if it's not there yet, then to 1, and then to 0. Okay, and the n matches, right? A sub 2 goes with x sub 2. A sub 0 goes with x to the 0 power. I'm sorry, not a sub 2 goes with x squared, a sub 1 x to the first, a sub 0 x to the 0. And if you guys remember, x to the 0 would be 1, so that's why you don't see an x there. All right, so a sub n is the leading coefficient. Notice that you've written these in order from the highest exponent to the lowest. And the degree is n, so that would match with the exponent right there. And of course, if they're in a different order, you can read them in order and be able to find what those are. All right. Multiplication of polynomials is done by the distributive property. So you're just going to distribute, and you can always just distribute. There are some useful formulas for multiplication. One of them is a plus b times a minus b, or a formula for multiplying something of that form. And your answer will always be a squared minus b squared, or of the form a squared minus b squared. Another one is when you're squaring a binomial, a plus b squared, or a minus b squared. And either one of those takes the same format in the answer. So a plus b squared will be a squared plus 2ab plus b squared. A minus b squared will be a squared minus 2ab plus b squared. And you can always just work it out using the distributive property, and you'll end up with the same answer. Let's try one. So letter C is an example. Multiply 1/3 x squared minus 6 quantity squared. So because it's a square and I have a formula for squaring a binomial, this is 1/3 x squared minus 6, so that matches with a minus b quantity squared. And so my answer should be of the form a squared minus 2ab plus b squared. So I'm going to write that, but instead of a, I'm going to put a parenthesis. Instead of b, I'm going to put a little parenthesis. So this is going to be then of the form a, or parenthesis squared, minus 2ab, which will be parentheses, plus b squared. So I'll put a parenthesis squared. All right, in the first parenthesis, the a is 1/3 x squared minus 2ab. So a again is 1/3 x squared. B is 6. And then the last one plus b squared, so that'll be plus 6 squared. Okay, so if I work that out, 1/3 squared is 1/9. X squared squared is x to the 4th. Minus 2 times 1/3 is 2/3 times 6 will be 4 x squared. And then the plus 6 squared is plus 36. So that's my answer right there. And of course, if I wanted to just distribute, I can remember square means you're multiplying by itself. So you would write 1/3 x squared minus 6 times 1/3 x squared minus 6. And then distribute. Some of you call it FOIL. So you would multiply the 1/3 x squared times 1/3 x squared, and the 1/3 x squared times negative 6, and then the negative 6 times 1/3 x squared, and the negative 6 times negative 6, and you'd have your 4 terms. So from the first binomial 1/3 x squared minus 6, you multiply the 1/3 x squared times the second binomial 1/3 x squared, and then 1/3 x squared times the second binomial negative 6. And then from the first binomial negative 6, you'd multiply that negative 6 times the second binomial. So you'd multiply negative 6 times the 1/3 x squared of the second binomial, and negative 6 times the negative 6 of the second binomial, and you'd get your 4 terms, 1, 2, 3, 4. Okay, I won't do it. If you ask me to do it in class, we'll look at it, but otherwise, you're just multiplying those terms. Let's go on to part 2, multiplying radical expressions. And so there's 2 examples, so we'll work out the first one, and the examples just say multiply. So number 1 is the quantity square root of 2 plus 3 times the quantity square root of 2 minus 3. So I noticed that matches the formula for multiplying a plus b times a minus b. It's of that form. So my answer should be a squared minus b squared. So I'm going to write that this is parentheses squared minus parentheses squared. My a is the square root of 2, and my b is a 3. This will be square root of 2 squared is 2, minus 3 squared is 9, and that makes that a negative 7. That's my answer. All right, and problem number 2, which is the quantity square root of 2x minus 2 square root of y, quantity squared. I'll let you do that. We'll do that in class, or we'll look at that in class. All right, let's continue with section R5, I'm sorry. So that was R4, and let's continue with R5, factoring. So first of all, factoring trinomials. To factor, you use the distributive property backwards. And you always start with a GCF. That means step number 1 is always, is there a GCF in the polynomial? And you factor it out, and then you use the distributive property backward. The only thing is, if you use it backward, well, it's kind of tricky, right? So it helps if you remember the formulas we just saw, that a plus b times a minus b is a squared minus b squared. Notice if you multiply, you can use the distributive property real easily, and it's harder to remember the formula. When you're trying to factor a squared minus b squared, you're trying to get back the a plus b times a minus b. And so notice there the formula is really helpful because it's really hard to see what was distributed to get that. Same thing with the one we saw where we had a plus b squared, quantity squared is equal to a squared plus 2ab plus b squared. Well, if you have a polynomial of the form a squared plus or minus 2ab plus b squared, then in factored form it would be a plus or minus b quantity squared. We also have sums and difference of cubes. So the sum of a cube would be of the form a to the third plus b to the third, and that factors into the quantity a plus b times the quantity a squared minus ab plus b squared. And then a to the third minus b to the third, the difference of 2 cubes, and that factors into the quantity a minus b times the quantity a squared plus ab plus b squared. Okay, so some pattern. So a to the third plus b to the third, the first factor is a plus b. Notice the sign matches. And when you're factoring a to the third minus b to the third, your first factor is a minus b. And then they both have a squared and an ab and the b squared term in the other polynomial that when you factor. When it's a to the third plus b to the third, you begin with a squared, then minus ab plus b squared. When it's a to the third minus b to the third, then that other polynomial, that other factor is a squared plus ab plus b squared. Okay, so the signs change in that second term, and they both have plus b squared. All right, let's try factoring a couple of these. Oh, but before we start, just some general notes about factoring, and you're supposed to be familiar with factoring. So you always check the GCF, and then you want to check to see, well, how many terms, and if it's got 2 terms, then the ones we know how to factor are of the form a squared minus b squared, or a to the third plus b to the third, or a to the third minus b to the third. Okay, after you factor out the GCF. If it's a trinomial, then we have the a squared plus 2ab plus b squared that we can use the formula to factor, but we can also factor using guess and check, and there's other methods. I'm going to use the guess and check. Okay, and we'll try it on the first example we do. So there's 2 examples. We're going to do number 2, which is to factor 2x squared plus 7x minus 15. And so guess and check assumes that this came from this. It's a trinomial, so you assume that this came from multiplying 2 binomials. Okay, and so I'm gonna open parentheses for 2 separate binomials. To get the 2x squared, you must have multiplied a 2x in your first binomial times an x in your second binomial. And so the first binomial starts with a 2x, the second binomial starts with an x. All right, to get the minus 15, that's a little trickier because that could have been negative 1 times 15 or positive 1 times negative 15, or negative 3 times 5, or positive 3 times negative 5. And then you got to decide, and then check with the distributive property to see which one gives you the plus 7x in the middle when you combine everything. Okay, so I'm going to take a guess and say that it's, so I look at the plus 7, and when I think about the plus 7, I think about adding, and I think about the factors of 15, I think about adding 10 and negative 3. So that means the 2x should multiply with the plus 5. So I'm going to put x plus 5, and then the 2x should have a minus 3 because the x should multiply by the negative 3. And I check in this way. So negative 3 times 5 is 15, so that's checked. But then I multiply the 2x times 5, the outside numbers, that's a 10x. The minus 3 times x, the two inside terms, and that's a minus 3x. And when I add those, I get 7x. And if I were to distribute this out, I would actually get 2x squared plus 7x minus 15. Okay. That's the shortest way, but notice you have to be very familiar with the factors. Otherwise, you can multiply 2 times negative 15, get a negative 30, and then find factors of negative 30 that add up to the 7x. That's called the A-C method. So if we do that, 2 times negative 15 is negative 30, and then the factors of negative 30 that add up to 7 would be 10 times negative 3. So you would split up that 7x, and you would rewrite this polynomial as 2x squared plus 10x minus 3x minus 15, and then factor by grouping. And factoring by grouping, you start by factoring the GCF from the first two terms, which would be a 2x. That would give you x plus 5. And then the second would be minus 3. That would leave you x plus 5. Then your common factor is x plus 5. You factor that out, and you get left 2x minus 3, which is the same answer that we just got. Okay. Well, I'm going to pause this video here, or stop it here, and then we'll continue on part 2 video.